is Mr. Ayton, and this is week 5, chemical reactions, and we are going to be taking a look at acid-base reactions. Now, before we begin acid-base reactions, we have to know all of our strong acids and our strong bases. In our strong acids, we have acids like hydrochloric acid, and hydrobromic acid, hydroiodic acid, nitric acid, which is HNO3, sulfuric acid, which is H2SO4, and perchloric acid, which is HClO4. You have to know these 6 strong acids, and you also have to know our strong bases, which are things like lithium hydroxide, sodium hydroxide, potassium hydroxide, anything in the alkali metals with a hydroxide, as well as the 2 lower ones in the alkaline earth metals with hydroxides, which are strontium hydroxide and barium hydroxide. Something you have to know about strong acids and strong bases are they dissociate completely. They dissociate 100%, which means they split up. So if you see a strong acid, if you see hydrochloric acid or nitric acid, split it up immediately and call it H+, because it has dissociated. If you see a strong base like sodium hydroxide or potassium hydroxide, split it up immediately into OH- or hydroxide. Now, you only have to know the strong acids and strong bases because anything that's not a strong acid or strong base has to be weak. I will show you a few common weak acids and common weak bases. The most common weak acids are acetic acid, which is HC2H3O2, and hydrofluoric acid, which is HF. Also, some common weak bases are ammonia, which is NH3, and then the hydroxides that are left, which are calcium hydroxide and magnesium hydroxide, left in that alkaline earth metals. And remember, do not dissociate these into ions. Keep these together because they do not dissociate completely. And that brings us to our reactions for this week. Our first reaction is equimolar solutions of sodium hydroxide and hydrochloric acid are mixed together. Right away we see we have equimolar, which means the same molarity, same concentration of these solutions. We take a look at sodium hydroxide, and we know that's a strong base. So we know it's going to dissociate completely, so I'm going to write OH- for sodium hydroxide. I see hydrochloric acid, I know that's a strong acid, and I know it's going to dissociate completely, and so that will be H+. What's going to happen when we have H+, a strong acid, with OH-, a strong base? We're going to get water. Pretty easy reaction, no need for balancing. Everything has canceled and balanced out. That's our first reaction. Our second reaction of the week is solutions of ammonia and nitric acid are mixed together. I need to know what ammonia is, and ammonia is a weak base. It is NH3. We're not going to dissociate that one. We're going to keep it together, and it's going to be mixed with nitric acid. Nitric acid is a strong acid, so immediately I'm going to dissociate it and call it H+. And so what's going to happen when I take NH3, a weak base, with H+, a strong acid, I'm going to be getting NH4+, which will be a conjugate acid. And so these are the reactions for week 5, acid-base reactions. Hope this helped. And tune back in a few more days for week 6. Thanks. Bye.